That angle there is theta. Parallel lines cut by a transverse. Alternate interior angles are congruent. So this would be the cosine, f cosine theta, f sine theta. And therefore, we can get rid of most of this stuff. What are my equations now?
F cosine theta plus y sine theta equals mass times acceleration. Yeah.
Good. And
F sine theta, or would it be negative, or it would be y cosine theta minus F sine theta equals m0.
Minus weight.
yes.
Oh,
Substitution, we have a formula for weight and the centripetal acceleration, and we have a formula for friction. We're at the cutting edge there, we're at the breaking point, and so we're at the maximum static, and so we end up with mu s y cosine theta plus y sine theta is equal to mv squared over r, and y cosine theta minus mu s y sine theta is equal to mg. We still have two unknowns, y and v. And the irrelevant mass. And that's an equal sign. All right. You can solve for y, plug into the other one just like we did before. It's obviously going to look more complicated. I'm going to suggest a slightly different route to get rid of y. I'm going to first factor y out. So this is equal to y times mu s cosine theta plus sine theta. And this is y cosine theta minus mu s sine theta. At this point, if we divide the left sides, looking at that relationship there, if we divide the left sides and divide the right sides, mass is going away, normal force goes away. So if I divide this side over here, I get this divided by that, which is just v squared over gr. And that's going to be equal to, well, I'm going to divide this side, my y's cancel out. I'm left with mu s cosine theta plus sine theta over cosine theta minus mu s sine theta. And now it becomes plug and chug, or I guess the speed is equal to the square root of gr times fraction us cosine theta plus sine theta divided by cosine theta minus us sine theta. I do a dramatic pause here for questions. Now we plug and chug. So that is equal to the square root of 10 times 100 times 0.8, and I'm just going to go ahead and cosine is 0.8. plus 0.6 divided by 0.8 minus 0.8 times 0.6. So it's 1,000 times 1.32. And 1.24. I must have Carol's error in there.
62.25 meters per second.
So by adding friction on this ramp, we can now go over 100 miles per hour and still not slide. Questions to hear before I change it slightly?
62.
Pardon?
62 meters per second.
62. So we're talking getting up near 130 miles an hour. All right, let's change it around a little bit. Instead of finding the maximum speed, let's find the minimum speed, so the car does not slide. What is going to change as we work our way down the process? Does the force diagram change now that I'm looking for a minimum speed?
Yes, because the friction will go the other way.
Yes. Because if we're driving under that ideal speed, the car wants to slide down the ramp, so friction is now acting the other way. And so it's acting up to the left. So I have F, S, cosine theta. F, S, sine theta. So its friction is acting in the opposite direction. That's the only thing that's changed there. Our equations, that's going to change. That becomes plus, and that becomes minus. Just following, let's do a quick double check. So we've got vertically in the j-hat direction, we've got 2 going up, 1 down, and then in the other direction, we've got 1 to the right, 1 to the left. Okay. So this is negative, positive,